Hi and welcome to my channel, and as per request, in this video I'm going to show how to solve the third layer of a 3x3 ghost cube. And so as you can see, the bottom layer is appears to be solved. The middle layer is also solved. The top layer is all messed up. Now the bottom layer is actually not solved because I've created a situation here intentionally in order to show you. I've swapped out two edges which are almost identical, top and bottom layer, and also two corner pieces which are very similar, top and bottom layer. Now these corner pieces are not 100% identical. They're about 95% identical. So if you're solving this very quickly and in a place where there's no good lighting, you might mix them up and you might get a situation where they're swapped, and this is called a false equivocation. Because what's going to happen is, if you try to solve it as such, you're going to get basically the entire cube solved and two corners are swapped, which is impossible in a 3x3. You're going to have to swap out the one from the top layer with the bottom layer to fix it. Also, the edge pieces, the one from the top layer and one from the bottom, they are even more similar than the corner pieces. With that being said, they are also not 100% identical. I would say they're perhaps 98% identical, so they are very difficult to tell apart. And even I myself, for many solves, I used to mix them up and how to get this false equivocation. And what happens in the end is whenever you solve the top layer, you end up with a situation where you get all the edge pieces in and the center is rotated 90 degrees, which is impossible. Or you end up with a situation where you have two edge pieces that are, properly attached to the center, and two of them that are swapped, which is also impossible. And in order to fix that, you have to swap out the edge with from the top to bottom. And so I'm going to show you how to do that now. So basically, swapping out the edge is more difficult than swapping the corners. And so the first thing you look at is, let's say you don't know about that, you have the situation right now. You've solved it, you think the bottom is fully solved, and you're up to the top layer. So what do you do at this stage? Well, first you have to, it's the same as on a 3x3. You see which ones are flipped and which ones are not. You either have all of them upside down, you either have the L, you either have the line, or you have all of them flipped properly. And in this case, you could tell, because this one is facing up on such a steep angle, that this one is properly oriented. This one you could also tell. With these, it's a little more difficult to tell if they're upside down or right side up, but the more you solve it, the more you get used to it. This one I could tell is properly oriented. This one, because I could see it's like kind of so low, and with basically I could just tell that this one is flipped upside down. And like I said, the more you solve it, you'll be able to tell easily. This one you could easily tell is upside down, and that's because this side of this piece should be on the bottom, whereas the pointy side should be on top. So let's flip them properly, and we do this with the basic 3x3 algorithm by holding with the L side that needs to be flipped like this, and we do this algorithm, which is going to form a line, and then we do it again, and it's going to place them all properly. So okay. So from this position, we do F, R, U, RI, UI. We would do FI to return, but since we need to do it twice, we don't need to return the FI because we're going to have to do F again. So we just do, again, R, U, RI, UI, and now we do FI to return it, and they are all now properly oriented. Now we try to properly place them. Now we could do this one of two ways. One is we could try to place them properly in conjunction with one another without regard to the center, or we could try to simply connect one of them to the center and place the other two, which is, you'll see, it's impossible in this case because one of the edges is actually flipped with the swapped with the bottom edge. So let's see. Okay, so if we do the Soon algorithm one time, this one is going to connect with that side, and let's see what happens. So the Soon algorithm is R, U, R, I, U, R, 2U, R, I. You can see, as predicted, this one is in, and as you see, this one is in as well. So we have a situation which is a false equivocation, because from this position, like if we hold these two pieces here and we do the soon again in order to place these, basically swap these, it will swap them and will place all of the edge pieces properly in conjunction with one another, but the center is going to be rotated 90 degrees. So let me show you. So we do the soon again. R, U, R, I, U, R, 2U, R, I. Now you see the edge pieces are properly placed as far as the solve goes in conjunction with one another, but the center is rotated 90 degrees. And basically we have an impossible situation. So what we have to do is going to have to swap the top edge with the bottom edge. Now to find it, you'll see you have one of these distinct edges on the bottom, or if, depending how you solve which one you start from the bottom or top, but you have one of these edges with this little kind of piece. And this one, you know, it belongs on this side because it doesn't have anything that's equivalent to it. This one, on the other hand, has an edge on the other layer which is almost equivalent to it. And you could actually, when solving this cube, you could avoid this situation, because if you really pay close attention, you'll see when you put in this corner piece, it kind of protrudes just a tiny bit, maybe like 1 millimeter. Like if you feel it with your finger, you'll see that it protrudes just a little bit. And this way you could tell right away when solving the bottom layer that this edge piece does not belong here. But let's say you missed it and you ended up with this situation. Now you have this here. So you know this one is going to have to swap with one of the top edges. How do you know which one? Pretty simple. You put in one edge that's shaped like this above it, and you try to basically turn it twice, see if it fits in. It does not fit in, so you know this one is no good. It has to be the other one. So this one right here, and you turn it in to test it out, and you see it does fit in. So you know that this one is the one that actually belongs on the bottom layer. Okay, so from this position, the way we swap them is as follows. So that one, the wrong one, is on the bottom right. The right one, we're going to put right here on the front, top front. So this is the first setup move. Second setup move is we do an R turn. And this brings this piece right here. Third setup move is we do a UI turn to bring this piece right here. And the reason we do these setup moves is because we want to put this edge into this position like this from that side. We didn't want to put it in from here because then it will be upside down. We have to put it in from this side going down. And from this position with these setup moves, we do the algorithm that puts in this edge here, and it's going to kick this one out to the top layer. And the algorithm is a regular 3x3 algorithm, which is UI, FI, U, F, U, R, UI, RI. Now we put that one here and it kicked that one out onto the top layer. Now the next thing we want to do is we want to fix that corner piece from the bottom layer, which was here and is actually now back there. So we do a 2U to put that corner piece, bottom layer corner piece, back in its proper place, and now we have to reorient it. So we do from this position without bringing this face down, keeping it up like this, we do RI, DI, RD to orient it. So RI, DI, RD, RI, DI, RD. And you could see that this one is now good, because if you place it on the bottom, you see it connects, so it's good. But in order to fix the bottom, as you know, RI, DI, RD, you have to do 3 sets of them to fix everything on that layer. So we put in a random piece and we're going to do RI, DI, RD in 2 sets on this one in order to fix the bottom, and then we put this one back. So remembering that we put this one here to our left side, RI, DI, RD, RI, DI, RD. We do it again, RI, DI, RD, RI, DI, RD. Now the bottom still looks messed up, and the reason for that is because we still never actually put back that layer, which is here. So doing this, the most difficult thing is the perspective and remembering what you're doing with the setup moves. So now we place this corner back into this position, connecting it with these 2 pieces. We bring this face back down, and you see the bottom layer is solved again, but this edge piece from the middle is now out, and it's actually right here. Yes, so we do a 2U to place it here because we have to put it in from this side, and you could test it out by placing it in. You see it fits in from the right going down. And so we do the standard algorithm to put it in. UI, FI, U, F, U, R, UI. Alright, places it in. Bottom is solved, the middle is solved, and we have that bottom edge piece now on top. So now we no longer have this situation of the false equivocation with the edges. We still have it with the corners, which I'm going to show you as we proceed with solving it. So once again, we see this piece, edge piece, is flipped properly. This one is upside down. This one, let's see, this one looks to me like it's flipped properly, and this one appears to be upside down. So we have an L situation where those two are good and these two are swapped. So we do that algorithm again in order to flip everything properly. F, R, U, R, I, U, I, R, U, R, I, U, I, F, I. And you see now they're all properly oriented, and we have one that's actually connected to the center. So we turn it like this, so we have this one here, and we do the soon algorithm, cycle these the other three, and we see we do it once, it's going to put this one where it belongs, and it's going to put all of them where they belong. So holding it like this, R, U, R, I, U, R, 2U, R, I, and you see all the edges are solved. We have the cross on the top layer. Now we try to solve the corners. We're not going to be able to do that, but let me show you what's going to happen. What I want to do to show this is I want to put these two big ones in their proper places. So I see this one belongs here, and this one belongs here. So I'm going to hold it like this to place them in, and you'll see that the little ones are going to be swapped. So we do the standard corner cycling algorithm, which is U, R, UI, LI, U, R, I, U, I, L. Okay, so now we do R, I, D, I, R, D on these two to orient them properly. R, I, D, I, R, D, R, I, D, I, R, D, R, I, D, I, R, D, R, I, D, I, R, D. We place this one into position to orient it. R, I, D, I, R, D, R, I, D, I, R, D. We have to do it some more. Now we've done 3 sets of R, I, D, I, R, D, which fixed the bottom layer. So we're going to have to do 3 sets again. We only need to do 1 more set to flip this properly. So we're also going to put in one of the other corner pieces, flip it twice, or flip one of the other, each of those 2 once in order to fix the bottom layer. So first from here, R, I, D, I, R, D, R, I, D, I, R, D. Let's put in this one. Actually, put in this one. R, I, D, I, R, D, R, I, D, I, R, D, R, I, D, I, R, D, R, I, D, I, R, and the last D not needed. Okay, so you see the entire cube is solved. Bottom layer is solved. Middle layer is solved. The top layer is almost fully solved, except you have these 2 corner pieces that are swapped, and this is a false equivocation, and the reason this happens is because one of these is on the bottom layer. And so once again, when solving this, like I said, they're not 100% identical. So if you pay attention, you're not going to get this situation, because if you look at the bottom layer, if you look at this one right here, you could feel with your finger that it protrudes, it sticks out. And also if you look really closely, you could see that it kind of sticks out a little more than it should. And you know this one does not actually belong here. Like when solving it, paying attention, you could avoid this situation. So you know this one belongs on the top layer. And you check which one of these it has to swap with. And in this case, I know it's this one. And you could also put it in like this, you know, to test it out, and you see it fits in. And the reason I know this is because solving it many times, I know that this long piece is not interchangeable. Also on the bottom layer, this kind of thicker piece is also not interchangeable. So you have these two, this one and this one, that are very similar, about 95% similar. So these two have to swap with each other. And how do we do that? So right now we're holding with this as our top layer. What we're going to do is we're going to flip the cube like this. So now this becomes our top layer. We turn it this way. And we're going to do the corner cycling algorithm. This is going to stay in place. This one is going to go here. This one is going to go here. And this one is going to go here. And we do that again. This one is going to end up here. This piece is going to end up here where it belongs. And this piece is going to end up here. Now, once this piece ends up here, it might not be flipped properly, in which case I'll show you what to do. But basically, this is going to resolve the false equivocation. So holding it like this with this as our top layer, we do the algorithm twice. U, R, UI, Li, U, Ri, UI, L. We do it again. U, R, UI, Li, U, Ri, UI, L. And in this case, we got lucky. This one is actually good. If this would have been oriented improperly, what we would do is we simply would turn it like this, keeping this as our top face. And from here, we would do Ri, Di, Rd to flip it. And once this will be flipped properly, we turn in another random corner, let's say this one, flip it twice or once, however many times is needed to fix everything on the bottom. We would turn this back in, and this layer would be fully solved. And then we would rotate the cube back. So this is once again our top layer. And now we could basically solve it. You see all the edges are still in their proper places. And now we simply cycle and we see this corner piece is in its proper place. So from this position, we do the corner cycling algorithm twice. It's going to place everything where it needs to go. U, R, UI, Li, U, Ri, UI, L. Once again, U, R, UI, Li, U, Ri, UI, L. And we see this one is already properly oriented, and this one, and these two are in their proper places. They just need to be flipped. So we hold it like this and we do Ri, Di, Rd, Ri, Di, R, D, Ri, Di, R, D, Ri, Di, R, D, Ri, Di, R, D. Put in the other one. Ri, Di, R, D, Ri, Di, R, and you don't need to do the final D, and yeah, and you just line it up, and we have ourselves a solved 3x3 ghost cube. And yeah, so that's how you go about solving the last layer on the 3x3. Hope this was helpful. If you have any questions, feel free to ask, and thanks for watching.